In this video, we're going to use Oscar to look at the Aldol reaction. So the Aldol reaction is a condensation which is of an aldehyde with itself, which is catalyzed by hydroxide or proton. So here let's do the hydroxide reaction first. So we have the aldehyde here, and we throw in some hydroxide. And what's going to happen? Well, we get a condensation where it takes two molecules, and in one case one forms an enolate and condenses into the carbonyl of the second one. So the one down here, the lower left, would have formed the enolate. The one on the top up here is the one whose carbonyl reacted. Now these molecules are all set up. This is called the aldol itself. So it's al for aldehyde, ol for alcohol. So this is an aldehyde with a beta hydroxy group. And these are susceptible to easy elimination if you add some more base. So add some more base, and we'll allow the elimination to take place. And so this is called your ene-al. So ene for alkene and al for aldehyde. So ene-al, it's a conjugated aldehyde. These could be useful molecules in a synthesis. Now, if you look down here, Oscar's giving you some notes. It says this is a self-condensation. The molecule's reacting with itself. And it says easy isomers expected. And this is a problem in these reactions, of course, is that you're actually getting two isomers here. And when Oscar does this reaction, one of them, somewhat arbitrarily, is drawn. In fact, if you do this reaction more than 10 times, you may get the other one showing up part of the time. So it gets a mixture, and that's just something you're going to have to be aware of. Now, you can also do this reaction in acid. So if instead of using base, we use a proton, and what you'll find is we get the same product. Here's the same product, but notice that it goes directly to the enal. It doesn't stop at the aldol, and that's simply because in the presence of acid, this elimination is much more readily happens, and so it's hard to stop it in the middle. But anyway, this is the simple aldol. Now we can do some more fun things. We can look at what happens if we try to do a crossed aldol reaction, where we have two different aldols in our reaction mixture. So let me just erase everything here. Let me center it, and I'll draw in a second aldehyde of some sort. Here I'll start with a phenyl group. And I'll give it a side chain with a second aldehyde group. Now the problem is, of course, we can get a real multitude of products. So what is Oscar going to do with this one? Oscar gives you two products, but one is off screen, so I have to make, because I didn't had it too big. But here is are your two cross products, because you can either form the enolate, the molecule on the left, or you can form the enolate with a molecule on the right. And whichever one you choose is going to govern your possible products. Now, again, if you look down here, more than one product possible, two aldehydes of alpha hydrogens. Oscar's figured out that you're going to have this product mix. But you actually get two more compounds than this, because each of these molecules could react with itself. Oscar's not showing you those products because it figures that you're not interested in those. Because if you're interested in the product of one of these molecules reacting with itself, you wouldn't put the other one in. But is this practical for synthesis? Well, you're going to have this prime mixture of four products, and you'll have to separate out the one you want. So it's not necessarily all that useful. Now, sometimes the crossed aldol does work. Let me just erase these two. And let's imagine that we don't have any alpha hydrogens on one of these. So let me just arbitrarily just go put two methyls there. So I just wiped out the possibility of forming an enolate here. Now if we do this reaction, we only get one product, because the only possible enolate is this guy reacting at forming enolate, and it'll condense in here. Now you still can get the cross product, or I'm sorry, the other product where this one reacts with itself. So there's still another possible molecule. But you're on your way to being able to do something practical. So anyway, this is the aldol reaction, and it is a useful reaction, but it is a little bit complicated because, in particular, you can often get these product mixtures.